Good afternoon, gentlemen. I'm Mort Rosenbaum, the Chief Engineer of Convair Astronautics. We are one of the many associate contractors who, together with the Western Development Division of ARDC and the Ramo-Wooldridge Corporation, are responsible for developing the WS-107A weapon system. This afternoon, we'd like to show you briefly, because our time is limited, the ground support equipment system which is required to support this weapon from the factory through maintenance to launch site and to impact. In order to do that for you, I want to show you some slides. Over here we have a sand table with some models, and beyond that, some mock-ups of some of the control equipment. So if you look over here, we'll see some of the models that I have to show you. I'd like to review with you very briefly the weapon system before we talk about the equipment necessary to support it. The weapon system is basically three parts: the missile and the nose cone and the guidance system. The missile is referred to as a 1.5 stage missile. It takes off vertically, goes into a programmed roll and pitch onto the proper trajectory. After some 2 minutes of flight, the booster section is jettisoned. We call it a 1.5 stage missile because when we jettison the booster section, we jettison the booster engine, the thrust structure, and some accessory equipment, but we do not jettison any tankage. The missile continues to fly on the sustainer and the vernier engines for some 3 minutes longer. At that time, the sustainer engine is shut down. The missile is brought to the right velocity by use of the small vernier engine. When the right velocity is reached, the nose cone is unlatched. Some solid propellant retro rockets are fired to give the missile body a little reduction in velocity so that it will separate from the nose cone. The nose cone then continues on to intersect the target. The entire time of flight from the takeoff to the target is about 34 minutes. The guidance system is shown by this slide. And you'll note that the first stage, the guidance system, is by programmed autopilot control. The guidance system itself tracks the missile but does not command it. In the second stage, the guidance system commands the missile through the autopilot by torquing the gyros to give the proper instructions to steer the missile on its course. The guidance system also gives you vernier cutoff at the right speed and, in addition, some discrete signals for destruct. Now, a little more detail about each one of these parts of the weapon system. The missile itself is shown by this slide. You'll note it's about 75 feet long, 10 feet in diameter, weighs 265,000 pounds, and has a fabricated weight of about 16,000 pounds. The tankage and the structure are common. It's thin stainless steel, completely monocoque, pressurized with helium so as to give it adequate strength and, in addition, to provide the right amount of head to the inlet pump of the power plant. There are two tanks, the liquid oxygen oxidizer tank being forward and the fuel tank containing rocket propellant fuel number 1 aft. The power plant is manufactured by the Rocketdyne division of the North American Aviation Corporation. Consists of three engines. You'll note in the slide the booster engine, the two outside thrust chambers, and one turbo pump provides 300,000 pounds of thrust. The center sustainer engine, which burns from takeoff through the second stage, provides 60,000 pounds of thrust. The two vernier engines, 1,000 pounds apiece. All five of these engines burn from takeoff. The electrical power is supplied by an auxiliary power supply manufactured by American Machine and Foundry Company. It's a turbine driven by the combustion products of liquid oxygen and missile fuel. It serves to supply all the electrical power for all the equipment, and in addition has a hydraulic pump mounted on it to provide hydraulic pressure and flow to the hydraulic actuators which actuate the sustainer engine. All of these engines, by the way, are gimbal. They're universally mounted so that they can swing in any direction and are actuated by hydraulic actuators through a conventional hydraulic system. The missile equipment, other than the propulsion equipment, that is the autopilot, the guidance, and the struct units, things of that nature, are mounted on this pod that you see in the slide on the side of the missile. The nose cone is shown in this slide. It weighs 3,500 pounds, as you see, and contains a warhead of 1,500 pounds weight. Protecting the nose cone on reentry is, as you know, a difficult problem because of the large amounts of aerodynamic heating. And you note in the slide that the nose cone is protected by a copper heat shield with insulation behind it. The nose cone also contains an attitude control device to position the nose cone into the right, to give it the right angle of attack as it enters the atmosphere. It also has arming and fusing provisions. The guidance system is composed of two basic sections. One, the airborne section, which is carried by the missile, and the other, the ground section. The airborne section is constituted by some canisters of equipment, a decoder, beacons, and some antenna. Now you'll note in the slide the guidance system represented by this slide of a sand table that we had of it, and the ground portion of it is also a duplicate system, two parts. The position system measures a missile position by means of a monopulse radar. The missile velocity vector is measured by the rate measuring system, which is shown on this slide. The rate measuring system consists of some antennas at the ends of orthogonal legs, and they measure the two components of velocity, so that with the position you can determine the missile velocity vector and its position. These signals are sent into the computer, which is positioned or placed in the guidance station, and the computer determines whether the position and velocity are correct. If they are not, it sends to the missile during the command phase the proper command signals to orient it on the right trajectory. Well, so much for the weapon system itself. The missile comes from the factory mounted in this trailer, which is designed so that it can be transported on the highway at a high rate of speed. It's steerable in the back, pulled by a standard fifth-wheel tractor. It also has provisions for supplying the gas required to maintain the proper pressure in the missile tank for structural reasons. The trailer transports the missile to the launch base or to an airport where it can be flown to the launch base. If the missile is placed in an airplane, you have a situation, something as shown on this slide, where we have a model of an existing airplane with a model of the missile in it. You'll note that the missile has to be partially disassembled. The thrust structure is removed and placed on a dolly, as is the tank. There are also provided pressurization equipment here to ensure that the tank pressure is maintained regardless of changes of altitude in an unpressurized airplane. When the airplane arrives at the airport which supports the launch base, the operation is reversed. The missile is removed, reassembled, placed back on this trailer, and towed to the squadron maintenance area. Now here we have on the backdrop a drawing of one of the early launch bases. The launch area in the front, in the foreground here, and in the background, the squadron maintenance area. The missile is taken into the squadron maintenance area. This model on the sand table is of that building. And in the squadron maintenance area is inspected for damage and checked out. Now take a look at the slide up here, and you will see a missile in checkout in the squadron maintenance area. The missile is plugged into the checkout equipment after the portable maintenance platforms have been placed around it, and after it has been inspected for any in-transit damage. The checkout equipment is over on the right-hand side of the slide. The checkout equipment is automatic. It interrogates the missile using a programmed procedure. It examines the response. If the response is correct, the missile is accepted. If in the event the response is negative in some area, the checkout is stopped and the particular faulty system or component is indicated, at which time, of course, it is removed and repaired or sent back to the factory for repair, perhaps, and a new and working unit installed. When the checkout is completed, the missile, still on its trailer, can be taken to the launch site. The nose cone is shipped from the factory in a nose cone handling and shipping container. Now, if you look at the slide here, you can see how this looks. The nose cone is mounted in this container for protection and transported in the lower half of the container, which also acts as a dolly. The nose cone is taken into the storage facility, not the squadron maintenance area, where it is assembled with the warhead, which is shipped separately. Its systems are checked out also in fashion like that of the missile itself. And in the slide, you can see a checkout operation of the nose cone taking place. Here we have a nose cone dynamic tester being utilized to test the attitude control device. The guidance station equipment, being of usual electronic nature, requires no special handling equipment and is shipped directly from the factory to the guidance station, a model of which we have here. The guidance station is a building located between the antennas, and I'd like to point out in this picture the antennas are different than those in the slide because this, being an early base, has earlier type equipment, Mod 2 equipment so-called, instead of Mod 3 equipment as shown on the slide. The guidance station, including the computer, and the tracking and command units, has two work areas at either end of the building. Well, so much for the receipt and checkout of the equipment. At this stage now, the missile, still mounted in its trailer, is transported to the launch site itself. And here's a model of the launch site. On the top deck is positioned the launcher, which serves to hold the missile in the vertical position and to release it. It also serves to erect the missile. Beneath the launcher is the flame deflector to deflect the flames away from the launcher and the launch site structure. At the launch site is this environmental shelter. This shelter is just that, an environmental means of protecting the missile from the environment when it is inside of this shelter. The shelter is positioned on rails so that it can be moved over the launcher and also removed when the missile is fired. The shelter rather, has movable work platforms to provide access to the missile. It has a hoist, and it is self-propelled so that it can move back and forth under its own power. In addition, it has communication equipment. Before the missile is brought to the launcher, the shelter is positioned over the launcher. The missile is then brought up in its trailer, fastened to the launcher, and by means of a winch in the shelter is erected. The nose cone is brought to the launch site separately, and a line is dropped down from the winch, the top of the environmental shelter. Nose cone is picked up in its hoisting sling, positioned on the front end of the missile, fastened there, and the missile is then complete. Umbilical cords are fastened. The lines that supply the fuel and the liquid oxygen are attached. The pressurization lines are attached. The other services are made ready, and the missile is ready then for checkout. Checkout is accomplished by means of the checkout equipment, which is in the blockhouse or launch control center. The launch control center is shown in this model. In the picture here, you see the launch control center in this position, surrounded by 3 launch sites. The launch control center contains 2 sets of checkout equipment, the checkout equipment being the same, to all intents and purposes, as the checkout equipment that is used in the maintenance area. In addition, it has 3 sets of control consoles with a launch control officer's console located behind them. Each set of control consoles controls 1 launch site. Only 1 missile is attempted to be launched at any one time. If the launch should be aborted for one reason or another, the crew moves to the other control console and launches a missile from the other site. Or if the launch is successful, they move and launch the missile successively. The total launch time is 55 minutes. Now, at this point, the missile is being checked out on the launcher. If the checkout is successful, it is then ready for the Readiness Plateau, you might say, in which the heaters are on, all the connections are made, the service tower, or rather the environmental shelter platforms have been lifted, and the countdown could start. In the event that something is faulty in the checkout, then the component is isolated and replaced. If replacement time of the component is longer than 2 hours, it is more economic, time-wise, to remove the whole missile from the launcher and replace it with a new missile and check that out, because this can be accomplished in less than 2 hours. Now, once we're at the readiness plateau, as soon as a command signal is given to launch the missile, the countdown can begin. The countdown takes 15 minutes. We have set up over here some models that we are using in developing the control console. We'd like to run through for you, in an abbreviated fashion, a 15-minute countdown to show you the sort of thing that has to be done.
T-minus 15 minutes. Remove environmental shelter.
Environmental shelter removed.
Pod cooling on.
Pod cooling on.
Hold down system pressurized.
Hold down system pressurized.
The panels require no decision on the part of the operators. They initiate the action called for by the launch control officer, and through the use of the light, monitor to determine that the operation is satisfactory.
On target Baker selected. Air burst. T-minus 13 minutes. Tank helium.
The panels are all integrated panels. In that complete system
T-minus 10 minutes.
are controlled by one panel.
Sequence 2.
Remember now, this is not in real time. We've abbreviated the time here because of our limitations.
Okay. Lock tanking. Lock tanking. T-minus 5 minutes.
The launch control officer, seated at this panel, monitors the entire operation through the use of his control lights.
Dump liquid nitrogen.
He also has the responsibility for pressing the start button. Once the button has been pressed, the countdown and the operation from there is completely automatic.
Roll 65 degrees left. Activate nose cone batteries.
Those cone batteries activated.
T-minus 2 minutes. Arm igniters. T-minus 60 seconds. Engine sequence started. T-minus 0, missile away.
In only 34 minutes, the target will be destroyed. Well, gentlemen, we've shown you some of the major components in the support system. Of course, we haven't shown you all of it. Time doesn't allow us to. There are many other pieces of support equipment that are required, such as test sets to test the canisters, harness test sets, hydraulic system test sets, and test sets to test the test sets. But in this limited time, I hope we have given you some feel for what's involved in supporting this weapon from the factory to impact.